It's no secret that when humans age, they tend to lose muscle mass. And this occurs even in some high-level elite athletes. There's no avoiding some muscle loss with age. You could see some of the great bodybuilders when they've tried to make comebacks. I won't mention any names, but anyone who follows bodybuilding knows who I'm talking about. Some of these guys were absolutely incredible, huge when they were in their 20s and early 30s. They tried to come back after age 50, and it just wasn't the same. They got in fantastic shape, but they just couldn't acquire the muscle mass that they had or what they displayed when they were in their 20s. And what are the reasons for this? Why do we lose muscle with age? What are the actual causes, and what could you do about it? It's a pretty complex subject, but let me at the very beginning, let me say right now, if you don't exercise, if you don't engage in resistance exercise, I mean, it's weight training mainly, it's inevitable. You're going to lose a tremendous amount of muscle mass with age, and it's going to start speeding up about age 40. It's going to be a downward trend from there. However, even if you do continue to engage in resistance exercise, anyone who's been training for years like I have can attest to the fact that things happen after age 50 that no matter what you do, no matter how much you train, no matter how well you eat, there's going to be some changes associated with aging, and you're going to just have to work around it. You could still stay in great shape. If you continue to exercise and eat a judicious, nutritious diet, your chronological age will be a lot less than your actual physiological actual age, I should say. In other words, a person 50 can actually have the physiological age of somebody 25 if he continues to exercise and stay in shape. But the important point I'm trying to make is he won't look like he's 25. There's going to be some obvious changes. Now, let's get to I'm going to talk a little bit about hormones at the end of this, but right now I want to talk about what goes on in the muscle to actually cause this aging effect. The first thing you have to talk about is something called satellite cells. Satellite cells are muscle stem cells that are heavily involved in the repair and regeneration of muscle. They're also involved in the muscle hypertrophy process. In other words, satellites, when you damage a muscle, I'm just going to simplify it here. When you damage a muscle, satellite cells, which are normally quiescent, they just lie kind of in between the muscle fibers. They just lie there normally, but when muscle's damaged, there are signals sent and certain hormones activate the satellite cells, and what they do is they function to help to repair muscle cells or muscle fibers that are damaged during exercise, and in doing so, they contribute what they call myonuclei, which I discussed in a past video. Myonuclei are involved in muscle protein synthesis, and they also remain in muscle for a time even after you stop working out. And this explains why you can take a layoff for a couple of months, come back and regain all the muscle because of these myonuclei that are contributed by satellite cells. Unfortunately, as people age, satellite cells tend to decrease in number, and they show an inability to renew and increase proliferation. This can result in fibrosis or kind of a scar tissue formation in the satellite cells, and an actual death of the satellite cells, which is called apoptosis, and that can lead to tremendous muscle atrophy, and the cells themselves can enter a state of senescence, where they're just sitting there, not doing anything, they're not replicating or anything. The good news about this is if you continue to engage in resistance exercise, weight training, even in older people, they found it can actually reactivate dormant satellite cells. So satellite cells are one of the main causes of the aging of muscle. Another primary cause is what they call reactive oxygen species. These are byproducts of oxygen metabolism, mainly produced in the mitochondrial portion of cells. Another name for them is free radicals. What they are unpaired electrons, and these unpaired electrons tend to lock on to paired electrons, which is a normal situation. And when that happens, they screw up the electrons. What this translates to is a breakdown of such structures as cellular membranes, fats, DNA, various structures in the body. free radicals associated with a number of diseases, cardiovascular disease, rapid aging, and also cancer. Now, when you get older, unfortunately, you have a built-in antioxidant system in the body composed of enzymes such as superoxide dismutase, catalase, and glutathione. Sadly, as people get older, these kind of inherent or endogenous antioxidant systems tend to decrease in activity. When that happens, you get an increase in reactive oxygen species, kind of like a vicious cycle. As the antioxidant protection in the body goes down, the reactive oxygen species increase and cause more and more cell damage. This is a major cause of aging, and it also, when you get older, these reactive oxygen species, they increase in satellite cells and muscle, and again, it leads to DNA damage to fats or lipids, and damage to proteins. And again, reactive oxygen species can definitely cause muscle atrophy as you age through those mechanisms. Another reason for loss of muscle with age is protein turnover. You decrease muscle protein synthesis after meals. In other words, as people get older, their ability to increase muscle protein synthesis following a meal containing protein is decreased. And there's ways around this I'll get to in a second. But another reason related to this is what they call dysregulation of autophagy. Autophagy is basically a catabolic process. It's the opposite of anabolic process. In other words, anabolic means the building up of muscle, something like that. Catabolic is a breakdown. Autophagy is a catabolic process, but it's important because it clears out dead old cells that get in the way of active cells. In fact, autophagy is needed in the muscle to clear out muscle debris and garbage that can build up in the muscle and interfere with muscle protein synthesis. So if you get a dysregulation of autophagy with aging, it can cause muscle atrophy, muscle loss. Autophagy is a very complex subject. I'm going to have an article on it. Of course, it'll be written in simple English, easy to understand, in an upcoming issue of my Applied Metabolics News. It's very, very important. Autophagy also features certain catabolic enzymes. I'm not going to get into that here. MRF1 is one of them. There's others. I'm not going to get into it here, but it'll be in my article. When you have this lack of protein turnover in muscle with age, it leads to a buildup in muscle, what they call protein aggregates, and this leads to impaired muscle function. Also, there's an anabolic resistance. Anabolic resistance has to do with when you get older, a lot of times you can't, it's very difficult to get the amino acids into muscle, even if you eat protein. However, recent studies show, again, good news, if an older person over 40 engages in resistance exercise, anabolic resistance disappears. And another way around anabolic resistance is simply, and this is important for older people, they have to eat more protein. In other words, because they can't process protein to the same extent as younger people, people over 40 need to eat more protein. There's a little trick. Let's say an older person that can't eat, let's say, large protein meals. Even if they eat a small protein meal, if they supplement it with, let's say, 3 grams of leucine, 3 to 4 grams of the branched chain amino acid leucine, it's almost the same as eating twice as much protein in that meal. Because you're getting all the essential amino acids, but the leucine activates them. So that alone is a way around this anabolic resistance. There's another possible cause of loss of muscle is fat infiltration of muscle and increased connective tissue in muscle. When the muscle fibers fail to, let's say, repair themselves properly, you get an influx of collagen, which is the main protein in connective tissue. And what this results is you get a greater amount of connective tissue in muscle. And unfortunately, that means it translates into decreased muscle size. You get a increase of connective tissue when the satellite cells fail to work properly. Also causes an increase of connective tissue in muscle, and this leads to muscle stiffness. You see the stiffness that people have when they get older; they get real stiff. A lot of that is again caused by an increase of connective tissue, and it's also caused by something else called advanced glycation end products. That involves the deposition of sugar molecules into protein structures, which weakens the protein structures. Again, a complex subject. Again, I'm going to have a total in-depth article on advanced glycation end products and how to prevent them or control them through nutrition and exercise in my Applied Metabolics newsletter. I will tell you that advanced glycation end products, the increase in the body is probably one of the main reasons why people get so stiff and can't move with aging. It's because of this infiltration of this stuff in muscles. There's also neuromuscular changes related to aging muscle. You get a decrease in motor units. Motor units are basically the innervation of muscle between the brain and the muscle. In other words, the brain sends out signals to the muscle, and these are transmitted to muscle through the motor units, the neurotransmitter being acetylcholine. But when you get older, some recent studies show that older people have as much as 40% less motor unit activity in their lower body. And this explains the old adage that, when the legs go first as you get older. And you'll notice in a lot of older bodybuilders, you'll notice that, if you look at photos of them when they were younger, and then photos of them, let's say, when they're over 50, their legs are always much, much smaller. And again, this is due to a loss of motor units. And once again, this is something that could be largely preventable. And I'm also going to have an article on that in my Applied Metabolic newsletter, how to maintain motor units as you age, which will have a tremendous effect at helping you maintain muscle as you age. Now, when you lose these motor units, you can also get a situation called fiber switching, where what happens is the fast twitch muscle fibers, which are the most, there's two types of fast twitch muscle fibers, but the important thing to know about them, these are the muscle fibers most associated with muscular growth or muscular hypertrophy. Unfortunately, as people get older, there's especially with a loss of motor units, there's a switching of these muscle fibers where the fast twitch fibers tend to atrophy while the slow twitch fibers tend to dominate. The bad part about that is slow twitch fibers are much less prone to muscular hypertrophy compared to the fast twitch, and they also show much less strength attributes. The slow twitch fibers are more associated with endurance, but they don't contribute that much to muscle size compared to fast twitch fibers. Another extremely important change with age to muscle that causes muscle loss involves changes in the mitochondria portion of the cell. The mitochondria are cigar-shaped organelles found in the cytoplasm of cells. That's the watery part of the cells. And what the mitochondria does, it's the site of energy production through a system called the electron transport system, results in the production of adenosine triphosphate, or ATP, which is the most elemental source of energy. The mitochondria are also the site of fat oxidation. Unfortunately, the mitochondria are also the main source of production of reactive oxygen species. The mitochondria have its own built-in antioxidant system, including stuff like coenzyme Q10 and a couple of other antioxidants. However, as people age, especially if they don't, if they don't, for example, ingest coenzyme Q10 or their body production lowers, these protective antioxidants in the mitochondria decrease, and this causes the eventual destruction of the mitochondria. And when you lose mitochondria, remember, the mitochondria are the powerhouses of the cells. When mitochondria basically go out, so does the muscle cells. And again, this is a major cause of atrophy, muscle atrophy with aging. And again, one of the main causes of loss of mitochondria is increases in reactive oxygen species and a decrease in the anti-activity that causes mutations in mitochondria DNA and the electron transport system. And this, of course, leads to more reactive oxygen. It's a kind of vicious cycle again. And again, the loss of mitochondria leads to muscle mass loss, I should say. Still another cause of muscle loss with aging is something called inflammation, systemic inflammation. This is inflammation throughout the body. Increased muscle inflammation is caused by an increase in inflammatory cytokines. These are proteins released by immune cells, such as tissue necrosis factor A, interleukin 6, and C-reactive protein. I remember reading there was an animal study a couple of years ago showing that if they gave substances to the animals that blocked these are older animals, if they gave them substances that blocked the release of tissue necrosis factor A, there was literally no loss of muscle with age. They did not lose any muscle whatsoever. So unfortunately, TNF-A, small amounts are involved in the muscle hypertrophy. You wouldn't want to knock it out completely, and it is important in the inflammatory process, which is it's important for health. Same with interleukin-6. It's a very people that are older tend to produce too much of it. It causes a breakdown of muscle. But when you work out with weights, when you do resistance exercise, interleukin-6 is involved in the anabolic process that produces hypertrophy after the muscle. So it kind of has two faces, this stuff. C-reactive protein is just a general indication of systemic inflammation. It's not specific, but when it's elevated, and you can have it tested in a blood test, it indicates that you have inflammation going on in your body somewhere. Again, increased reactive oxygen species caused by decreased activity of an endogenous antioxidant. Again, as you get older, your built-in antioxidant enzymes, such as superoxide dismutase, catalase, and glutathione, tend to decrease, and this causes a lot of the problems of aging. It causes oxidation of DNA, and it interferes with satellite cell function. I'd be amiss if I didn't mention some of the hormonal causes, which are much more familiar to most of you who are looking at this video. It's pretty well established that men tend to lose their testosterone levels tend to drop after age 40. Actually, it starts about 30, but it's 1 to 2% per year. By the time they're 50 or 60, they can have very low. Again, it varies with the individual. Some men hardly show any changes in testosterone at all as they age. Why? Nobody knows. But other men show drastic decreases in testosterone, and testosterone is needed to maintain muscle mass. Of course, there's an easy solution to this, is to go to a doctor and have lab tests done for testosterone. You want to have the total testosterone, free testosterone, and something called high sensitivity estrogen is also important. You should have 3 tests done, not consecutively. Let's say one week, one the next week, one the third week. Best time to do is early in the morning when testosterone levels peak. If all 3 tests show that you're low in testosterone, taking or getting on testosterone replacement therapy would make an incredibly huge difference in the extent of muscle mass loss. It'll go a long way towards preserving muscle mass with aging. Same goes with growth hormone. Growth hormone is a little bit more iffy. I kind of believe that most men, if they're deficient in testosterone, should go on TRT, but I'm not so sure about growth hormone for a number of reasons, and I've mentioned this in other videos. For one, if you take testosterone, the active anabolic portion of growth hormone called insulin-like growth factor automatically increases, and that's the part of growth hormone that maintains muscle. So you don't actually need growth hormone itself. And I'm also concerned because growth hormone, it's related to the promotion of certain types of cancer, especially through the IGF-1 system. But more importantly, animals that are lacking in growth hormone activity live much longer. So, the amount of growth hormone they give for growth hormone replacement therapy, I don't think it's a problem. It's very small amounts, just enough to kind of overcome a deficiency of growth hormone. But I'm not a big fan of growth hormone therapy. Let me put it this way. However, some people take it if it helps you, fine. It does have an anti-aging effect in muscles. But again, I think that if you take testosterone, you'll be pretty much covered for IGF-1, which is the active component of growth hormone for muscle. And of course, there's something called the insulin resistance of aging. This is related to physical inactivity for years. What happens is these people most of them aren't even fat. Insulin resistance is usually related to having too much body fat. But in older people, the insulin resistance comes from poor blood circulation to the muscle. Because of the lack of what they call microcirculation, these small blood vessels, they can't get enough proper delivery of amino acids into muscle. And so what happens is they lose muscle mass. They can't get the protein into the muscle, so they lose muscle mass. This is related to called the insulin resistance of aging. The good news is that it can be treated easily by 2 methods, either actually taking insulin or by taking insulin or by just exercise. Resistance exercise cures the insulin resistance of aging. Very simple. So that's about it. Now you know the main causes of loss of muscle with age. Some of these things are a little kind of inevitable, but they could be minimized by judicious weight training. When you don't overtrain, you don't go crazy, you don't overdo it. When you're over 40, you're going to need more rest between workouts. You're going to need less volume. In other words, fewer sets. If you train that way, you'll go a long way towards preventing muscle atrophy. In fact, you could probably completely arrest it, most of it, except for the legs. Because of that motor unit effect, there's always going to be some loss of muscle in the legs. And the other thing, of course, is good nutrition, ensuring a good amount of protein and all the other nutrients that are needed. So that's about it. If you want more information on nutrition, exercise science, hormonal therapy, ergogenic aids, anti-aging techniques, fat loss methods that work, subscribe today to my Applied Metabolics newsletter, www.appliedmetabolics.com. As I said earlier in this video, I cover a lot of topics that are not even touched by these other digital publications. My newsletter is written in plain English. I've been a professional writer for 40 years. I know how to communicate in the written word, and my newsletter is understandable by anyone who's gotten as far as 6th grade. I guarantee you, any technical terms that I have to use, I will explain. The newsletter is 40 to 50 pages every month, no ads, just pure, solid, evidence-based information. I guarantee you'll learn something in every issue, no matter what your level of education. And after a couple of months, you yourself will be an expert on nutrition and exercise just by reading my newsletter, because I literally cover the waterfront. Anyone who's a subscriber knows I don't leave anything out. In every one of these articles, you learn everything there is to know about something. So subscribe today, www.appliedmetabolics.com. When you subscribe, I'll send you an invitation to join my private Applied Metabolics Facebook page, where each day I post new information about nutrition, exercise, and general health information. I also have an email portal on my Applied Metabolics website. Subscribers can ask me short questions, which I will answer. I don't answer unsolicited questions. In other words, questions not submitted by subscribers. I don't answer those. You have to be a subscriber, a current subscriber. You're welcome to leave comments under this video. I can't guarantee I will answer them. I do answer questions submitted only by my subscribers. Sometimes I'll answer I'll answer comments under the videos, but there's no guarantee of that at all. If you want to have the best friend you'll ever have, go to your local shelter, adopt a dog. They are the best. Take care.